Alright, so we want to graph the logarithmic function by plotting points. So in order to be able to plot points, we have to be familiar with evaluating the logarithmic function. So if you recall, to evaluate the logarithmic function, I'll come off to the side, we're looking at what power do I raise the base to that would give me the number on the inside. So in this case, it would be 3 to the second power would give me 9, so my answer would be 2. From this, what we can take away is whatever's inside the parentheses. In order to evaluate this without using a calculator, whatever's inside the parentheses has to be a power of my base. So what are the powers of the base of our base 3? So like 3 to the -1 power is going to give me a third. 3 to the 0 power is going to give me 1. 3 to the first power would give me 3. 3 to the second power would give me, like we said, 9. So this will give me 4 values, so that might be enough. So these values are what I want the number inside the parentheses to equal. So I'm going to get some x values going on and some y values going on. And if I want whatever's inside the parentheses to equal 1, think about what would x have to be to give me 1? Well, -1 plus 2 would give me a +1. So if I plug in -1, then I'll get log base 3 of -1 plus 2 minus 1. And log base 3 of -1 plus 2. -1 plus 2 is +1. So this would give me log base 3 of +1 minus 1. And so now we can go ahead and evaluate. 3 to what power gives me 1? And it's 0. 3 to the 0th power gives me 1. So log base 3 of 1 turns into 0. So I get 0 minus 1 is equal to, running out of room, is equal to -1. So if I plug in -1, in this case, I end up with -1. So there's 1 point on my graph, -1, -1. Now, let's go to 3. So I want the number inside my parentheses to be 3. So what number would x have to be so that I would get 3 inside the parentheses? And the answer is 1. If I plug in +1, then 1 plus 2 gives me 3. So I'm going to plug 1 in for x. So 1 plus 2 gives me 3. So I get log base 3 of 3, because I plugged in 1. 1 plus 2 is 3. Minus 1 equals, so now here we can evaluate the logarithm. 3 to what power gives me 3? And it is 1. 3 to the first power gives me 3. So this logarithm simplifies to 1, and I still have that -1, which gives me 0. So that tells me if I plug in 1, I get 0. So we'll keep going. 9 is a number that I can evaluate the log base 3 for. So again, I'll ask myself, what would my x value have to be so that the inside of my parentheses is equal to 9? And in this case, it's 7. If I add 2 to 7, I do get 9. So plugging in 7, I would get log base 3 of 7 plus 2, which is 9. And then again, I have to subtract 1. So I can evaluate that logarithm. Log base 3 of 9. So again, thinking 3 to what power would give me 9? And the answer is 2. So log base 3 of 9 is 2. And then I have this -1 out here. So I get 1. And we can do one more. So a third. I know that I could evaluate log base 3 of a third because I get 1/3 from raising 3 to some power. So what would I have to plug in for x to get a third? And the answer is -1 2/3. If I do -1 2/3 plus 2, I get a +3rd back out. So if I plug in -1 2/3, then I'll get log base 3 of -1 2/3 plus 2 gives me a third. And then -1. And now I can evaluate that logarithm. 3 to what power gives me 1/3? And the answer is -1. Remember, the negative exponents tell you to take the reciprocal or flip that value over. So log base 3 of 1/3 gives me -1. And then I still have to subtract that 1, so I get -2. So I've got a good bit of points here. I do still want to identify what my vertical asymptote is. So we get the vertical asymptote from the horizontal shift, which can be found inside with x, so whatever's being added or subtracted from x. In this case, I'm adding 2, so that's an indication that I'm going to the left 2. And the parent functions of the logarithms have a vertical asymptote at 0. So if I'm shoving it back 2, then I'll end up with a vertical asymptote of x equals -2. So I have the vertical asymptote, I have a good bit of points, so I'm going to go ahead and graph this now. Alright, so I'm going to start by plotting my vertical asymptote. So I know my vertical asymptote occurs at x equals -2. And now plotting my points. If I plug in -1, we found that I should get -1 back out. So if I plug in -1, I get -1, boop, right there. If I plug in +1, then I should get 0. So if I plug in +1, I get 0. If I plug in 7, then I'm up at +1. So 1, 2, 3, 4, 5, 6, 7. I'm up at +1. And if I plug in -1 and 2/3, so this is in between -1 and -2, I should get -2. So a little bit closer to -2, I should get -2. So about right here. And so we can kind of see an outline of what that graph should look like. I'm conforming down very close to my asymptote and then veering off to the right hand side. And this is a pretty accurate sketch of log base 3 of x plus 2 minus 1 by plotting points.